Another mainstay of Wolfram language, of course, is all kinds of beautiful visualizations. We've been doing a little bit of work here. The first is actually around the things I've just been showing you, which is as we've been improving model fitting and data smoothing, one of the workflows that's come up on the list of things to improve was a really standard thing that lots of people do over and over again, which is you've got some data, you want to fit a model to it, you then want to plot the data and plot the model so you can see the two side by side and compare. And we've made that now a single step exercise. So there's this new visualization command, list fit plot. And in this case, I'm just grabbing some air temperature data on Champagne over a period of time, which is it's actually grabbing the data that's taking the time here, but hopefully in a moment that will come in and you'll see what we get. Hopefully. There we go. So in a single function now that takes just the raw data, I've achieved both I've done the fit and the data and plotted the two together. And in this case, it's handling data objects automatically over the X interval. And there's a bunch of ways you can control that. You can control the model for fitting. You can decide what elements you want to see. So, for example, you might show that same thing without the data, but with the upper and lower bound 95% confidence intervals. It works in 3D as well. So here's an equivalent in 3D with, again, I'm asking here for the band surfaces, but in 3D, there's a new little kind of visualization featurette here, which is that when you've got three surfaces going on with some transparency, it gets a little bit confusing to see when you're seeing through and how close they are together. So there's this new feature of band of pillar points where just little pillars are put in between the surfaces to give you a sense of how close the surfaces are when you're looking through a surface. So we can see here, even though we can't quite make out the underlying surface, we can see from the very small band pillar that surface is quite close over there and increasingly close as we get to the corner. There's a new just filling in a very obvious gap in the space here of, if we get the accidents data back in again, smooth date histogram. We've had smooth histograms. We've had date histograms, but we've never had smooth date histogram. So now the ability to take that data and give a joined up smooth version of the density of values. So we can see here, regardless of the severity of accident, we can see that there were a dip in accidents in London during April. I guess that was Easter, and during the summer when everyone's on holiday. But otherwise in that year, the trend was generally upwards without having to do the bin counts and a smooth histogram of the bin counts. Now this one's getting into the details, but it's the kind of thing that makes a difference between sometimes a presentable, publishable plot and an unpublishable one. If I pick on feature space plot, but this is a general thing across lots of plots, here's a typical labeling problem. There's an awful lot of points in this feature space plot of flags and how similar they are. So you can't label, well, you could label all of them, but it's made an automatic decision here to label some of them to give you a sense of some interesting points that are in the extremes or in the middle of that set, and has decided not to label things that are close together. Up to now, that kind of labeling was either you had to explicitly write a labeling command for each data point, and you might write some code that would map that over all of the points, but you had to take control of each point, or you had to accept what feature space plot is doing here, which is automatically doing it. And we've now filled in a middle space where there's this labeling target function, which takes all kinds of parameters. One of the simplest is to say all, which is a way of saying I want to label every point in that. So we're going to get a rather jumbled plot here, but everything has been labeled. Maybe if I zoom this in enough, that would be useful. Or I can provide all kinds of parameters. So I can say, for example, I want to label 3% of the plots, try to avoid overlaps. And here I've kind of turned down the density of labeling to approximately 3% of the points have got labels on. So there's various things you can control here about maximum overlap and labeling fraction and other parameters that lets you use automation, but not in a take it or leave it kind of way. In the end, it's that kind of thing I think we need to be doing a lot more of in the Wolfram language, because the more automatic things are, the more useful they are. And in a system as big as Wolfram language, it's that kind of automation that makes 5,000 functions usable without you having to spend hours learning the syntax of every single detail of every function. So yeah, more controllable automation is a key feature. This one's a small but again very Wolfram-y kind of thing we've had around for a long time. you could do list plots of data points with error bars on. But around has been essentially a numerical function up to now, that it takes numbers and we can do numerical computations on that. So I could do a calculation like what happens if I add two of those things, but it's never supported symbolic things. And we're trying to make everything in the language that can work with numbers work with symbols. So what does that mean in this case? Well, now you can have things like function plotting where the error interval is a function of, well, it could be a function of anything, but here it's a function of the dependent variable, in order to put on things like error bounds onto plots where there is a functional description rather than a data description. And you'll probably see the connection here with the new visualizations and the way that our fitting and smoothing now feeds smoothly into visualization, needs things like around just to generally work more seamlessly so that these things all join up nicely. And joining up is what we like to do. Again, supporting 3D. So here's a simple plot of x plus y where the error is x times y, and you can see the error grows as we head towards the top right corner of the plot. Right. Few other things to skip through quickly here. Interactivity has been one of those things that we've built into a lot of the plots for a long time. So as a simple example, pie charts, you can click on them. You may not want that though, because what if you don't want somebody interacting with your document? You just like it the way it looks. Also for efficiency, if you're just exporting the thing to a PNG or an SVG or a JPEG or something you don't care about, generating that interactivity, throw it away. So now we have a plot interactivity goes to false on a lot of plots where I can click on this, but it doesn't do anything now. It's killed the interactivity. So it's sort of downgrade in a way, but keeping you in control of these things. There is a couple of new graph layouts. So for graphs and networks, there are these two new layout mechanisms that place the points progressively on a Poincare disk. And I'm not going to bother showing it here, but GeoGraphics now have new vector rendering, so it's faster, and that's allowed us now to flip GeoGraphics to use vector graphics by default. So they'll be crisp and sharp at any print resolution, and already I've started making use of that. If you check out a resource function I wrote recently, it allows you to decompose graphics, GeoGraphics. So I've got a resource function that says, I only want to plot forest cover and roads. Don't show me anything else. Or I only want the buildings to be shown in this plot. Or I want to style buildings red and roads in green. And you can now control those things because the default graphic has got lines and polygons in it that have semantic labels, rather than just being bitmaps, which was our default before.